Hello all, this is Dr. Srilatha, working as Senior Assistant Professor in the Department of Mathematics in Vallurpalli Nageshwara VIGNANA JYOTHI Institute of Engineering and Technology, Hyderabad. So today I'm going to explain the brief about non-homogeneous system of equations, how to solve. So what are the different cases we learned in previous video? If the rank of the augmented matrix is equal to rank of A, in that case the system is said to be consistent. If it is consistent, what type of solution we'll be getting? Is it unique solution or infinitely many solutions? So if the rank of augmented matrix is equal to rank of the given matrix capital A is equal to number of unknowns, if all these three conditions are equal, in that case we can say that the system has a unique solution. If rank of A is equal to rank of augmented matrix, both are equal. Suppose you got the rank as 3 and here our number of unknowns are 2. That is R is less than N. If this condition, in this case, we'll be getting infinitely number of solutions. And the third case is if the rank of matrix is not equal to rank of augmented matrix. In this case, the system is inconsistent. Inconsistent means the system has no solution. Now, moving on to next slide. So we are having some example problems. Now solve the system of equations. We're having three different equations here. Now coming to the solution. The first step is we'll write the given system of equations in the form Ax equal to B, where capital A is called the coefficient matrix and capital X is the number of unknowns, capital B is the constant matrix. Now what are the coefficients of x plus y plus z? 1, 1, 1. And the second equation 2, 5, 1. And the third equation 2, 1, minus 1. So this is the coefficient matrix capital A and the number of unknowns capital X, that is x, y, z, which is equal to the constant matrix 9, 52 and this is 0. Now define the augmented matrix, that is A given B. So we'll write the augmented matrix as which is equal to, so the coefficient matrix and the combination with the constant matrix 2, 5, 1, 2, 1, minus 1, drawing a line here, 9, 52, 0. Now we need to reduce this augmented matrix into echelon form. So with the help of this element, I need to make all the down elements are equal to zeros. Now what are the operations I need to implement here? Now applying R2 tends to R2 minus, here I am having 2, now multiply this with 2, 2 minus 2, this becomes 0. Next R3 tends to again 2, R3 minus 2R1, 2 minus 2 which is going to be 0. Now my augmented matrix is approximately equal to, since I am not implementing any operation to the first row, I am writing as it is 1, 1, 1, 9. Now here this is going to be 0, 5 minus 2, 3 and 1 minus 2 minus 1 minus 2 minus 1 and here 52 minus 18, this is 34 and now this is going to be 0, 1 minus 2 minus 1 and here minus 1 minus 2 minus 3 and this is 0 minus 18. Now the next operation is with the help of this element I need to make the down element equal to 0. Now what is the operation I need to perform here? Now apply R3 tends to, now multiply this with 3, 3R3 plus R2. Now my augmented matrix is approximately equal to, now write the first two rows as it is since I'm not performing any operation here. Now 0, 3, 5, 34. This is 0. Now this is going to be 0 and this is minus 4 and here minus 20. If you observe this matrix, the number of zeros are in increasing order. If the number of zeros are in increasing order, that is nothing but this matrix is in echelon form. If this is in echelon form, next what is the rank of the matrix here? Therefore, rank of A equal to total number of non-zero rows. How many number of non-zero rows are there? 3. Next, define the rank of augmented matrix. If you take the whole matrix, again we are having 3 non-zero rows. And how many number of unknowns are there here? Number of unknowns, which is equal to x, y, z, which is also equal to 3. If rank of A is equal to rank of augmented matrix, if this condition is satisfied, we can say that in this case the system is consistent. If it is consistent, then what type of solution will be getting here? That means if rank of A is equal to rank of augmented matrix, we got this as 3, that is the rank R, and here this is also equal to 3, that is the number of unknowns. So in this case, the system has unique solution. So if R is equal to n, the rank is going to be the number of unknowns. Here we got the rank as 3 and the number of unknowns are also 3. So in this case, we can say that the system has unique solution. Next, we need to find what are the values of the number of unknowns, that is x, y, z. So how can you calculate here? Again, by using the reduced echelon form matrix. Now the system of equations can be written. System of equations from the reduced echelon form matrix. Reduced echelon form matrix. So we'll be having the matrix as 1, 1, 1, 0, 3, 5, 0, 0, minus 4, and the number of unknowns as x, y, z, which is equal to 9, 34, minus 20. Now, the first equations from the back, here the equations can be written in the form x plus y plus z is equal to 9. Let's give the equation 1. 3y plus 5z is equal to 34. Let's give the equation 2. And minus 4z is equal to minus 20. Let's give the equation 3. So from backward substitution method, from equation 3, we got the value as z is equal to 5. Now substitute this z value in equation 2. 3y plus 5 multiplied with 5, that is 25, which is equal to 34. That implies y is equal to 3. And from equation 1, x plus, we got y as 3 and z as 5. This is equal to 9. From this, x is equal to 1. Therefore, capital X equal to the number of unknowns x, y, z, which I got the values 1, 3, 5. So, this is the complete solution. Next move on to another problem. Again, the first step is given system of equations can be written in the form Ax is equal to B. Now write the coefficient matrix capital A, write the number of unknowns, and capital B matrix. What are the coefficients here? 1, minus 4, 7, 3, 8, minus 2, 7, minus 8, 26. Now the number of unknowns are x, y, z, which is equal to the capital B matrix. The constants are 14, 13, and 5. Now define the augmented matrix, that is A given B. Now the combination of both AB matrices, that is 1, minus 4, 7, 3, 8, minus 2, 7, minus 8, 26. So I'm drawing a line, 14, 13, 5. Now I need to reduce this augmented matrix into echelon form by applying the elementary row operations. Now applying R2 tends to R2 minus 3 R1. Since you are having 3, it is 1. I'm multiplying again with the 3. 3 minus 3, that is going to be 0. Next, R3 we are having 7 and R1 you are having 1. Now multiplying R3 minus 7 R1. Now here the augmented matrix is approximately equal to, since I'm not performing any matrix to the first row, I'm writing as it is. That is 1, minus 4, 7, and this is 14. Now this is going to be 0, and this is 8 plus 12, this is 20, and this is minus 23, and this is minus 29. Now this is going to be 0. Again, this is also 20 minus 23, and here minus 93. Now, with the help of this element, I need to make the down element equal to 0 by implementing the row transformation as apply R3 tends to, since you are having 20 minus 20, so I'm taking the operation as R3 minus R2. Now, my augmented matrix is approximately equal to, since I'm not performing any operations for first and second row, I'm writing as it is 1 minus 4, 7, and this is 14. This is 0, 20, minus 23, minus 29, 0, 0, and this is going to be 0, minus 64. Now, if you observe this augmented matrix, again the number of zeros are in increasing order. So, I can say this is in echelon form. If this is an echelon form, then what is the rank of a total number of non-zero rows? So here 2, and what is the rank of augmented matrix? So here rank of augmented matrix is equal to 3. If you observe, the rank of augmented matrix is 3 and the rank of a matrix is 2. Therefore, we can write here rank of A is not equal to rank of augmented matrix. That is, the system is going to be inconsistent. If the system is inconsistent, then it has no solution. So previous problem we got it, the system has unique solution, and now we got it, the system has no solution. Next, moving on to the another example. Again, we are having 3 system of equations. Now given the system of equations can be written in the form. So always we'll be writing capital AX is equal to B. Now write the coefficient matrix, the coefficients of first equation 1, 1, 1, 1, 2, 3, and 1, 4, 7. So the number of unknowns are X, Y, Z. And the constant matrix is 6, 14, 30. Now, define the augmented matrix. So here the augmented matrix is defined as A given B. That is a combination of both AB matrices. So I will be writing 1, 1, 1, 1, 2, 3, 1, 4, 7. Just I'm drawing a line. 6, 14, and 30. Now, again I need to convert or reduce into echelon form. Now, what are the operations I need to implement here? Since all are ones, R2 minus R1, 1 minus 1, 0, and R3 tends to R3 minus R1, 1 minus 1, that is also going to be 0. Now, the augmented matrix is approximately equal to, since I'm not performing any operation to the first row of the matrix, I'm writing as it is. So here 1, 1, 1, 6. Now this is going to be 0, 2 minus 1, 1, 3 minus 1, 2, 14 minus 6, 8. And this is going to be 0, 4 minus 1, 3, 7 minus 1, 6. And now 30 minus 6, 24. Now the next step is, with the help of this element, I needed to make the down element equal to 0. What is the operation I need to implement here? R3 we are having 3 and R2 you are having to multiply R2 with 3. Now apply R3 tends to R3 minus 3R2. Now my augmented matrix is approximately equal to, since I'm not performing any operations to the first 2 rows, I'm writing as it is 1, 1, 1, 6, 0, 1, 2, 8. And the remaining, this is going to be 0, this is 0, and this is 0, and now this is also going to be 0. If you observe the reduced echelon form, the number of zeros are in echelon form here. Therefore, how can I write the rank of a matrix? Number of non-zero rows. How many number of non-zero rows are there? Since the last row is a 0 row, because all elements in that rows are equal to zeros, we can call this as a 0 row. And remaining 2 non-zero rows. Therefore, I can write as rank of a matrix A equal to 2. And what about the augmented matrix here? Again, this is also equal to 2. Therefore, they both are equal. That is, rank of A is equal to rank of augmented matrix are equal. Then we can say that the system is consistent. If the system is consistent, then what type of solution you will be getting here? So it depends on number of unknowns. That is, n is equal to 3. Therefore, rank of A is equal to rank of augmented matrix, which is equal to 2, that is equal to R, but it is less than n. That means, so here number of unknowns we are having, this is 3 unknowns, but you got the rank as 2. Therefore, here the condition it is satisfying R is less than n. In this case, the system has infinite number of solutions. So how can I calculate this infinite number of solutions here? Again, by using, with the help of the reduced echelon form, we will be writing the matrix here. The system of equations from the reduced echelon form matrix. So here I will be writing here 1, 1, 1, 0, 1, 2, 0, 0, 0. And the number of unknowns are x, y, z. And here you will be getting 6, 8, 0. Since you are having infinite number of solutions, we need to choose n minus r arbitrary constants, where n stands for the number of unknowns and r stands for the rank of the matrix. So unknowns 3 minus 2, which is equal to 1. That means I need to choose one arbitrary constant. You may take either x equal to k or y equal to k or z equal to k. Let z is equal to k, where k is an arbitrary constant. So using this one, the system of equations, what are the equations you will be getting here? X plus y plus z is equal to 6. Let's give the equation 1. And y plus 2z is equal to 8. Let's give the equation 2. Now by using from equation 2, just substitute here z equal to k. That is y plus 2k equal to 8. That implies y is equal to 8 minus 2k. And from equation 1, x plus 8 minus 2k plus k, which is equal to 6. That implies x is equal to k minus 2. Therefore, the number of unknowns, that is capital X, is equal to x, y, z, which is equal to k minus 2, 8 minus 2k, and this is k. That means if we go on giving the different values for k here, that is why k equal to 1, k equal to 2, k equal to 3, like that up to so on. For k equal to 1, you will be getting one solution. For k equal to 2, you will be getting another solution. And for k equal to 3, another solution. Like that, if you go on giving different values of k, we will be getting different solutions here. That means the system has infinitely many solutions. So these are some example problems that is related to the non-homogeneous system of equations, where you will be getting the consistent. If it is consistent, what type of solution you will be getting? Either unique solution or infinitely many solutions. If it is inconsistent, that means the system has no solution. So these are the things you need to keep in mind. I hope you understood all these problems. Thank you all. Thank you for watching.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.